right. Proofs are not easy. Okay, I'm going to give it to you. Proofs are not easy. But the more you do, the better you get. Okay, let's look at number 7. We're going to do this together. So we are going from congruent to congruent. So I'm going to use that definition of congruence to be able to do the work with equality signs. So we're going to rewrite this. Without the congruent, and it's equal, and that's definition of congruence. Easiest thing other than reflexive that you will ever get in a proof. We can actually go ahead and do this down here. Put it back with the congruent, and we have that one done. So now we're just working in the body of the proof. Okay, let's see what's going on. Now, something that I love that this proof does is it shows you that not all things are drawn to scale, and you got to go with whatever the person gave you on the paper. So AB is equal to CD. Obviously, the way it's drawn, that is not true, but we're going to mark it, and if I put the same marking, then it is true. BD is congruent to DE. Double markings to show those are congruent. And I'm trying to show that AD is congruent to CE. Now, do you notice I'm going from little piece to a big piece, and little piece to a big piece? Whenever that happens, I'm going to have to do something with addition. And it may be that we use the segment addition postulate because I have segments and a substitution, or sometimes we will use the addition property of equality in our work. Okay, so again, there's no way for me to tell you that every proof is going to be like this because every proof is different. Okay, all right, so we've got our pieces that are equal. And then we have this statement right here. Your eyeballs need to get used to seeing when you have two things equal to a third thing, you have to look up at the picture and see, is this segment addition postulate? Because that should be one of the easiest things also for you to get in the proof. AB plus BD equals AD. Here's another way you can know that it's segment addition postulate. Do you see how these are the same? Those would be the letter ends in between these two letters, and then these two letters end up being the letters are here. That's segment addition postulate. Okay, segment addition postulate. Then I've got CD plus DE equals AD. Well, let's look at our picture. CD plus DE. Okay, so it's not segment addition postulate because it doesn't say CE. All right, so that means something's happened, maybe a substitution. Let's check it out. Well, these stayed the same. The AB turned into a CD. Is there anything telling me that those are congruent? Right here. So I can take out the AB, and I like to do this so I know that AB is replacing, or CD is replacing AB. Same thing here. This one turned into DE. Is there anything telling me these are equal to each other? Yeah, it's right here. So BD turned into DE. So that is our substitution. Property of equality. Okay, so then it tells me I have another segment addition postulate. I've already had this segment addition postulate, so we're going to use this one. CD plus DE equals CE. Segment part plus part equals whole. Now, here's another thing that I'm teaching you that you need to look for. When we go from to where we have things that are equal to each other, we have to find how they were set equal to each other. And when you guys are writing proofs, this is not easy, okay? But you get better at it the more you do. I like to circle or highlight things that are the same. So do you notice that this and this are the same? Circle it or put a box around it. We'll do that. If you can put boxes around things that are the same, then what they're equal to are also the same. Think of it this way. I like using money. If this is $10, this represents $10, then this has to represent $10. Well, this is the same as this. This is $10. So this has to be equal to $10. That means 10 equals 10. These two can be equal to each other. This is how we're doing transitive property, but you can also put substitution. Miss Gina Wilson, who writes these worksheets, likes to put transitive. So watch. It's backward though. Engine, train car, caboose. Engine equals caboose. Okay, the engine is pulling the caboose because we can take out the train cars. The train cars are exactly the same. Okay, so that is a proof. All right, so now we're going to do this one and try to write it by ourselves. First thing we do is we write down our given. We always number our statements and our reasons. And when you're writing down the given, you write it down exactly like it is. Your statements and your reasons are always numbered and they always line up. Don't put a 2 here and then a 2 here. Okay, they always line up. All right, so because we're going from congruent to congruent, but I want my work to be done with equality, we need to put in this step right here. So let's rewrite it. Remember I said you could abbreviate congruence. All right, let's see what's going on in our picture. Let's mark this in our picture. GI equals JL. So I'm just going to darken this up. This whole thing is equal to this whole thing. GH is equal to KL. And I'm trying to show that HI is congruent to JK. Do you notice that I'm going from something big and I'm ending with something little? That tells me that we're still going to use SAP, segment addition postulate, but I am most likely going to have subtraction, okay, because we are going from a big segment and we're ending up with little segments. Opposite from this, we went from little segments and ended up with big segments. We didn't have addition, but we had substitution that helped us. Again, not all proofs are the same. Okay, so let's go ahead and put our segment addition postulate in here. Okay, GH plus HI equals GI. Okay, I'm going to give you another tip or trick. Most of the time, I can't say all the time, most of the time, substitution or transitive will follow segment addition postulate. That's a tip trick. So most of the time when you have SAP, it's going to be followed by substitution or transitive. Okay, most of the time, not every time. So I need to see, based on that little tip that I'm giving you, I need to see if there's something that I can substitute in here. So we have all of these. Let's just replace what we have in here. So GI is going to turn into JL. GH is going to turn into KL. Let's number this. Okay, so we have KL plus HI equals JL. We did some substitution, and what I did was I replaced this one, and I replaced this one because of step number 2. That's substitution. All right, we've done everything we can do with that segment. So now let's go to the other segment. We're going to need a segment addition postulate, and then we're probably going to have another substitution. So because we had this piece right here, that's bringing us into this other segment. So let's do that segment addition postulate. JK plus KL equals JL, segment addition postulate. Most of the time after segment addition postulate, we're going to have another substitution or transitive property. So let's see if we can kind of figure out what's going on with this. All right, I've got the JL here, which kind of makes this nice. I've got the KLs, which are the same in here. I need to see if I can replace this with anything. Can I? Doesn't look like it, but let's see. What are we doing? JL. Oh, I think I know what we're going to do. I think we are now going to put boxes around these. And because those are equal, we're going to be able to put these two equal to each other. And that's that transitive step, like engine to car, car to caboose, engine equals caboose. Okay? That's hard. I know it's hard. But that's transitive. If you put substitution, it would be correct. Don't forget, we're still supposed to be putting POE. Again, try to remember. Not going to count it wrong if you don't, but try to remember. All right, now let's look at step 6. This you will get used to. Okay, let's look at step 6. I told you up here that because we're going from bigger segments to smaller segments, there's going to be some subtraction. Okay, is there anything on here that's the same on the left and right? The KL. So we are going to get to subtract the KL. However, anytime we subtract something, we're supposed to have a reflexive step in there. So put 7. We're getting ready to get rid of the KL. That is why we use the reflexive. Okay, KL is on both sides, and now I can get rid of the KLs. KL gets rid of over here, gets rid of over here. This step right here is sometimes left out of proofs. Again, it just depends on who's writing the proof. But look, I've got HI equals JK, which is what we're trying to get to. And we subtracted KL on the left, we subtracted KL on the right, so this is subtraction. I added step 7 in, so we're going to need a step 9 to finish the proof because this is what we're trying to get to. So step 9 is put the congruence back in there. Remember, something on top, something on top. And that is definition of congruence. Okay. All right, here's worksheet 15. I want you to see that you're going to be filling in the right. And I want you to try that, okay? Everything that I showed you in those notes is going to be something that will help you figure these out. All right, so I'll let you try this, this, and this. So basically 1 through 6, you're going to try together. Try to work together and do. You're going to have lots of things that are happening. You're going to have vocab word. Remember vocab, the word trick that I'm teaching you. Vocab word, congruent. That one, they didn't have to go back to being congruent because they didn't ask you to. But this one, from congruent to equals, back to congruent, things like that. Okay? And then when you get to this step, it's like what you did with the peel and sticks, but hopefully you're getting a little bit better at it. And it's the same things we've been doing. And then I'm going to do these with you in class. Okay? Actually, I'm going to go ahead and do some of these with you now. So when you're in class the next time that I see you, you're basically going to be doing 1 through 9 together, and we're going to work on these right now. Okay, so we're on number 10. You're expected to write this down with me. Okay, so y is the midpoint of xz. What you ask yourself is, what does a midpoint create? A midpoint creates two congruent segments. So I want to teach you something. When you are doing a proof, you mark your diagram. Okay, you mark your diagram. Now, when I mark this diagram and I do this, does it say up here in the given xy equals yz? No, so that is something I'm going to have to put in the body of my proof. Okay, that is something I'm going to have to put in the body of my proof. So after you mark your picture, if there's anything that wasn't written exactly right here as the given, you have to put that in the body of your proof. And then remember, what we're trying to prove most likely will be, actually this one's only going to have 6 steps. So sometimes I give you more lines than you need. Okay, in fact, all 3 of these, we don't need the last line. It's there in case we do need it, but sometimes we don't. Okay, so let me get the given down. You can abbreviate midpoint. Okay, this next step I now am going to expect you to be able to get. When I give you that you have a midpoint, you are going to tell me 2 congruent segments. X, Y is congruent or equal to YZ. We use equal because the definition says a midpoint creates 2 segments that are the same length, and length is equal. Okay, so this is definition of midpoint. Circle this vocab word and draw an arrow, because I want you to get used to seeing that as well. Okay, we're trying to show that xy is half of xz. So we are probably going to do some substitution, okay? But we've got segments. Let's get the segment addition postulate in there, okay? xy plus yz equals xz. That is our segment addition postulate. Now, I don't know if you can see already what's going to happen, but I am going to make a substitution. Okay, I'm going to make a substitution. Possibly. I'm worried about this. I keep thinking that in order to get a half, we got to have a 2 somewhere. We got to double it so we can divide by it. So let's see. What if I do 2xy equals xy plus yz? Okay, I think I'm going to use the addition property. Again, this is the part you may not know, but I'm going to use the addition property, and I am going to, what am I adding? 2xy. No, okay, it's kind of a substitution, and 2xy equals xz. This is what the person's doing. I'm going to do a substitution step, and we're going to use all 7 steps. Okay, I'm going to say xy plus xy equals xz. That is something you guys can follow that I did. Xy plus xy, I did a substitution, equals xz. Okay, now step number 5, I've got 2xy equals xz. So I combine like terms. I think I'm going to let you guys go ahead and use simplify. All right, so now all we have to do is division. We are going to end up with 6 steps after all. Divide by 2, and we get xy equals, when we divide by 2, we don't put it over 2, we use fractions. And that's exactly what we're trying to prove, and that is division. POE. Okay, that was not a hard proof. All right, number 11 is actually a very classic geometry segment proof. I would probably put one like this on your test. So I want you to really pay attention. All right, first of all, let's write our given. Okay. Now, what did I tell you? The next step would be if we've got from congruent to congruent, we're having congruent at the beginning, the end. So what do we have to do our work in the middle? Change it to equality. Okay, so this is the definition of congruent step. So step number 2, rewrite it with equals. You can use the congruent symbol, that's fine. Okay, let's see what's happening in our picture now that we got that down. It says AC is congruent to DF, so that's the whole thing and the whole thing. Not really a good way to mark that. Sometimes I just make it darker. Okay, and then BC is congruent to DE, and I'm trying to show that AB is congruent to EF. So just by looking at this, I know I'm going to have both segment addition postulate problem or statements. Do you guys know that it doesn't matter where you put the segment addition postulate as long as what comes after it makes sense? Okay, so it doesn't matter if I put this one first and this one first or a step in between. It doesn't make the proof wrong if the order is out of order as long as it's logically coherent. Okay, so you can also put the segment addition postulates in the same step. I'm going to split it up into 2 steps. Okay, so I'm just going to put my segment addition postulate steps here. So my question for you that I'm going to grade you on is for this statement right here, what would you write here if my reason is SAP? Okay, again, what would you write here if I'm using this segment to make it segment addition postulate? Go ahead and go and pick your answer. Okay, did you get it right? Very good. Okay, and then we're going to do the same thing for the next one. DE plus EF equals DF, segment addition postulate. Again, those could have been written as one step. I could have put 3 and then just wrote these and put 3 and wrote it one time. It's perfectly fine, and either way, it just depends on how you wish to write it. Now, guys, pay attention. If I give you little pieces and we've got segment addition postulate statements, we're going to do some substitution. And what did I say on the previous notes? That typically after you have segment addition postulate, you are either going to have substitution or transitive. Okay, so get used to that. So now that I have, sometimes you have both. Now that I have my statements, let's substitute in there. Okay, so AC is equal to DF. So we're going to write, we're going to take out the AC, we're going to put in a DF. AB, now watch, okay, I've also got something here that I can substitute. We can take care of that in one step. So AB plus DE, and then AC is turning into DF. All right, so if you need help understanding what we just did, from 3 to 5, we took out the BC and we replaced it with DE. We took out the AC and we replaced it with DF. BC turned into DE, AC turned into DF based on this step right here. You should understand that. I don't think that's hard. That is substitution POE. Okay. Step number 6. Is there anything in here that we can substitute? Let's see. AB plus DE, AB plus DE equals DF. AB plus DE equals DE plus DF. This is what I'm looking for. I want you to notice now, since we have the substitution step, I want you to notice that these are the same. Now we have both statements equal to DF. So when I told you before in a previous proof, when you have both statements equal to the same thing, remember like $10 equals $10, $10 equals $10. So because these two are the same, that means these two are the same. That's transitive. Engine to middle car to caboose. Engine, middle car, caboose. That's the transitive property. This is what you're going to write down. DE plus EF equals AB plus DE. And that is the transitive. If you put substitution, it's okay. Let's not forget what we're trying to prove. Look up here. AB is congruent to EF. We're going to have two more steps. Do you see an AB and do you see an EF? Okay. Look, if I cover those up, look at what's on the left and look at what's on the right. All right, we've got to get rid of that. We're actually going to have three more steps. Okay, we're going to get rid of that. Remember what I said, anytime you add or subtract something, you're supposed to put a reflexive step. So let's put step 7. And let's put DE equals DE, reflexive. The reason I'm putting that in, not everybody puts that in, but I want you to remember that whenever you're adding or subtracting, it's always a good idea to see what you're adding or subtracting. And then if you get used to having a reflexive, addition and subtraction, most all of the time follows reflexive. So now I'm going to subtract DE from the left and the right, and we have EF is equal to AB. Okay, so that is subtraction. And I'm going to tell you why we actually have two more steps. I'm going to tell you why we have two more steps. The person, when they wrote this proof on my answer key, they put these two in one step, the SAPs in one step, and they didn't add the reflexive. So I'm going to have to squeeze in some other steps. So number 9, okay, number 9, we need to get this switched around. Okay, AB over here, EF over here. AB equals EF. That is symmetric property. Just POE. There we go. And then we have to end up with congruent. I'm going to squeeze that step in right here. We're going to say AB segment is congruent to segment EF. And then reason 10, we are going to say definition of congruence. I love adding those extra steps in because I think it's a good idea for you to see them. Okay, we're going to do this one in class.